batteries are generally degrading slower than initially thought. A battery which is degraded will have a slightly higher internal resistance than a new battery, and therefore you get more temperatures, less current, and therefore doing very hard, aggressive trading with those batteries might not be as effective or less efficient than with a first life battery you've got off the shelf.
So this state of health number doesn't really capture all of the nuances and difference. It's like a general thing, but there's more to it than that.
I mean, if you think about it, we're going to have hundreds of megawatt hours of batteries coming off of our vehicles in the coming years. We don't want to wait until then to start figuring out what we're going to do with them. Build the capability now, understand these batteries, make sure we can deploy and operate them, we can return value and operate them safely and effectively. By proving those revenues now rather than later, you can underwrite that residual value, potentially even increase it, and the earlier you can potentially increase that residual value, then the more competitive you can make the pricing for the first life batteries.
The cool thing about an islanded grid with a battery and a generator is you have this thing to measure, which is how much fuel is the generator drinking. And as long as it's drinking less fuel than it was, that battery is a net positive to that system, which is awesome.
Hello everybody, welcome back. You are listening to Modo, the podcast. Today we are joined by Robert Long, Business Development Manager at Zenobe. Q and Rob explore how Zenobe are repurposing the batteries taken from their electric bus fleet and giving them a second life. If you're enjoying the podcast, please hit like and subscribe. It really means the world to us. Let's jump in.
All right, Rob. So, which employee number are you at Zenobe?
I couldn't tell you with 100% confidence, but I think out of people still at the company, excluding the founders, I think I'm the fourth longest serving full-time employee.
So an OG at Zenobe.
That's what they call me.
And were you there before it was called Zenobe? Were you there before
No,
the
I
name
joined
change?
just after the rebrand,
Just
thankfully.
after.
Joining Best Limited wasn't quite as sexy as my friends.
And what's Zenobe up to these days?
Zenobe is continuing on the original paths that we started on, so accelerating in the network infrastructure side of things, building large-scale batteries to support the grid, including a significant pipeline of batteries being built in Scotland over the next few years to tackle some of the constraints we see there. At the same time, in 2019, we started supporting fleet operators with the electrification of their fleets, helping overcome the barriers on charging infrastructure, getting enough power to the site, as well as the financing of the vehicle and the battery on that vehicle, crucially, themselves. So we're continuing on that and expanded that across Europe, Australia, New Zealand, and more. And then what I'm focusing on is the second half of that story. What do you do with a battery once it can't be used on a vehicle anymore? When its useful life on that vehicle is finished, how do you extend the economical and environmental benefits of that battery by repurposing it and using it in a second life?
So Zenobe's got a lot bigger. I think when friend of the podcast, Stephen Mearsman, came on when we first started doing this thing, which feels like forever ago, Zenobe was like 100 employees. You had the big battery business, utility scale batteries. You were doing some bus stuff, like pioneering bus stuff, but it wasn't that big yet. And then you were looking at second life stuff. So since then, you guys are now over a couple of hundred now. How many people are there at Zenobe?
I think we're just short of 250 today.
Wow. And there's 3 divisions, right? So the stationary batteries, the buses, which I talked to Stephen a lot about in the pod. Do listen if you're interested in that. And then now your bit, which is taking those batteries and doing something else useful with them.
Exactly that. So at the moment, none of the vehicles that we're financing and the batteries that we own on the vehicles are old enough where we've had to replace those batteries. But we don't want to wait,
What does that mean in years? Like 2 years, 5 years, 10 years?
Well, exactly. I would say first batteries we'll see coming off, still depending on a lot of factors, will be in 2 to up to 5 years' time.
Okay.
There's still a lot of factors that can impact that a lot.
And these are buses that are going around every day doing routes and just...
Yeah, you've got buses doing up to 150 miles a day. They have to do that on a single charge. When they can't do that 150 miles a day on a single charge, they're no use for the operator on that route.
Okay. And then you guys are going to strip those batteries out and do something with them.
Yeah, well, first, what you might want to do is actually, if you have enough vehicles with one operator, is look at rotating vehicles around onto different routes. So you maximise the first life of that battery before you then remove it and put it into a second life.
So the shorter route, you get the older batteries on shorter routes and the longer duration ones on longer. That makes sense.
Makes sense, right? Yeah.
So I guess rural communities are going to get the brand new buses, and cities are going to get the older buses. Is that how it works?
In theory,
In theory.
I guess then the other aspect you have to look into is the air pollution targets, which are probably more focused on urban areas where you have much more vehicles, and that will be the priority for electrification.
And how many buses do you guys have at the moment?
In terms of vehicles that we're supporting in one way or another, we've got over 1,000. So that's not currently operational, but that's contracted.
Okay.
And that number's maybe a couple of months old. So by now, I'm sure it's a lot larger.
And so there's about 1,000 buses out there, Zenobe buses, doing their thing. And then you guys realised at some point these are going to become end of life, and the batteries are worth something.
Mm-hmm.
So do you want to talk through that? What's the use case for batteries that have come out of buses? What can you use them for, and what's special about them when they're old and used compared to new?
Okay, so a battery which has been on a bus, let's say, for 8 years, give or take, and it's degraded down to 80% state of health. You might have...
What does that mean? Sorry. 80%.
State of health is on day one, let's say it's a 100 kilowatt hour battery. On day one, 100% state of health. You can charge it up to 100 kilowatt hours and get that much energy out of it. On year 8, at 80% state of health, you can only get 80 kilowatt hours out of that same battery. Effectively, some of the lithium ions have got stuck or they can't be used anymore, and therefore every time you charge and discharge it, you get less energy out. The same way that your iPhone or smartphone can, on day one, last 2 days. After 3 years, you have to charge it twice a day.
Okay, and those, I'm going to let you finish in a second, but I've just got another question. The batteries in the fleet that you have,
Yeah.
are they generally doing better or worse than you thought when you first started modelling these and getting warranties and all that stuff?
Yeah, I think, which is fairly common across the EVs and the stationary battery market, is that batteries are generally degrading slower than initially thought. Maybe that's because of OEMs were being initially conservative in the warranties they were offering. But yeah, we see that they're lasting longer, and if you optimize how they're charged, how they're driven, then you can definitely give them a longer life.
This is how you see these 1,000,000-mile Teslas and all that stuff, right?
Exactly.
So you take the batteries out of the buses and they've got less state of health, roughly 80%.
Yeah.
And then what does that mean? What does that mean you can use this for and you can't? Or can you just use them everywhere with less state of health?
In some ways, I mean, so first off, it won't necessarily be 80%. Like I said, if there's an opportunity to move that 80% battery onto a different route where it can operate down to 70%, then that's the preferential choice.
Okay.
But when that battery comes off, effectively you test it and you characterize its condition, and the characterization of that battery will maybe tell you what it can and can't be used for. So as a rule, a battery which is degraded will have probably slightly higher internal resistance than a new battery, and therefore you get more temperatures, less current, and therefore doing very hard, aggressive trading with those batteries might not be as effective or less efficient than with a first life battery you've got off the shelf.
Because of the round trip efficiency of the whole system, because it gets hotter and it's just more painful to use. Yeah.
Exactly that. So that's one thing to consider. Another thing to consider is that two batteries, which are both degraded to 80% capacity, might have degraded for slightly different reasons. The factors which cause that loss of 20% may be different, and that might cause those batteries to behave differently in the rest of their degradation. So there's different types of degradation mechanisms. And so even though you might test them and they might have exactly the same amount of energy, if you put them into two systems which go into identical applications, those two batteries may then behave differently and degrade differently over the rest of their life.
So this state of health number doesn't really capture all of the nuances and difference. It's like a general thing, but there's more to it than that.
Exactly.
So how does your business, let's go back to the Zenobe business model. Am I right in saying that Zenobe has all these buses and stationary batteries, and then it gets to end of life, say, we're going to call them end of life, but I know there's probably some other words to describe it. And then you go, oh, actually, we're actually sitting on an asset here if we can use it in the right way, and we can eke more value out of these things.
Mm-hmm.
It's like the residual value of these batteries after 10 years. It's not zero, right? It's more than that.
Exactly.
And so you guys are trying to figure out how to get the most out of them, which is probably a good thing for the environment too. So an 80% state of health battery, how do you make a decision whether to reuse it or to recycle it or to do something else with it?
Like I said, you categorize it. So you test it. So you dismantle it from the vehicle and you run some tests on it. At the moment, those tests take a fair amount of time. So you're doing some cycles and you're measuring, or you're sampling a lot of data as you do those cycles to see, one, the capacity, and then other things like the behavior of voltage, temperature,
Who does these tests? Do you guys do it, or do you get?
Yeah, we work with people. We work with various parties who can perform these tests, and we state our requirements in terms of what those tests need to look like to satisfy our requirements for the applications that we want to put the batteries into.
This is right at the cutting edge, right? Because I assume there's no standards. Are there standards of these types of tests? Are there standards in what acceptable is, what performance looks like? We're really into the deep niche of the next phase of batteries here, aren't we?
Yes, the standards, there are some standards. Mostly the US has some specific standards around second life. The rest of the world, the IEC standards are catching up. So there aren't real specific guidelines in what is required. It's more based on experience, what you think you need to know in order to operate effectively and safely these batteries in a second life.
And what are the options for second life batteries? Where can you put them? What kind of use cases do you have for them?
So at Zenobe, we've deployed second life batteries in two different applications, mainly stationary and mobile applications. So on the stationary side, we've put them into over 1 megawatt containers. We've used them on industrial sites where we've got them, for example, in Belgium on the Artsen site. We have a battery which is charging from excess solar, using that to power the site in the evening during expensive energy periods, at the same time providing balancing services to the grid. So a similar kind of behind the meter battery model that you might have seen in the UK or other markets. But we've also used them to support EV charging. So we've recently been building the Coventry Electric City depot for National Express, where we've got over 130 vehicles charging.
Massive, isn't it?
And we've got a 1.2 megawatt second life battery supporting the charging by optimizing on-site solar and overcoming the grid limitations on that site.
So still involved in buses, but at a bus depot, not on a bus.
Yeah, I think that's the nicest
nice
part of
about
the story.
that. Yeah.
And the other thing that's nice about that is that battery. So obviously the second life modules in that container, they're not going to last as long as a brand new battery would, but that container and the infrastructure within it will last. And so when those modules start to not meet the requirements, they reach the end of their useful life, we can remove them, and then we can take new second life batteries, which have come off slightly newer buses, for example, and they can go straight into that container and support the charging of even more electric buses. So that really is the kind of circular economy story that we want to be able to reach.
I mean, all transport is like, I've got a 2-year-old, right? So all transport's like a little animal or person. And I can think about, because that's just all of the TV that she watches. And I'll just think about all these buses going out doing their daily stuff. And then they get back to base and they're sort of end of life. And they go back to this little retirement home next to the base and help everybody out. It's pretty cool.
Yeah.
And so what about safety on second life batteries?
Yeah, obviously it's like new batteries. It's obviously the first concern when you're operating a battery system. So really what we rely on is very good communications with OEMs who can give guidance on how batteries should be operated, early in life and later in life. Make sure that you're comfortable in the parameters those batteries should be operated within. So voltage limits, temperature limits, cycling limits, and then build a system which has a comprehensive enough monitoring, control, and fire detection and suppression system, so that everyone or you as the person operating it are comfortable with it, the manufacturers are comfortable, and the customers are comfortable.
What sort of volume of systems do you have or capacity installed out there in the real world? Is this like a couple of pilot projects, or is this, I don't want to say, is it a real deal? Do you know what I mean?
Yeah, no, absolutely. We see it as a real deal. So we have currently operating, we have about 2.5 megawatts of stationary batteries, but we have, I would say, about 5 megawatts of mobile batteries, second life batteries, and we have a pipeline of much more than that. So we're hoping to have between 15 to 20 megawatts probably before the end of the year of second life batteries in operation.
Wow. It's pretty serious.
Well, I mean, if you think about it, we're going to have hundreds of megawatt hours of batteries coming off of our vehicles in the coming years. We don't want to wait until then to start figuring out what we're going to do with them.
Yeah.
We want to build the capability now, understand these batteries, make sure we can deploy and operate them. We can return value and operate them safely and effectively. But also, by proving those revenues now rather than later, you can underwrite that residual value, potentially even increase it. And the earlier you can potentially increase that residual value, then the more competitive you can make the pricing for the first life batteries.
So your business case for the first part of the business of stationary storage completely changes if you've got a back end of this residual value, which proves these things aren't worth zero. Actually, they're worth half the value or 3/4 or whatever the thing is.
Exactly.
It changes the whole project economics.
Well, exactly. So if you've got a customer who, let's say they've got a depot of 100 buses, and they've been told to electrify all of them, they might look at the current costs of how much it costs for them to get that vehicle financed, and they might only be able to do 10. If you can increase that residual value, maybe they can do 12, 13, 14, 15, I don't know. But the other side of it is that by demonstrating that second life batteries, one, can provide value, and two, can be used to offset more carbon emitting technologies in a second life, then you increase the environmental benefit of those batteries as well. And it kind of answers some of the questions brought up by people who say, okay, well, batteries are fine, but what about the resources that have gone into mining and manufacturing and processing those batteries? If you can really maximize the environmental benefits, then not only are you making it cheaper in the first life, but you're also answering those questions and bringing more people on board to the idea of electrification.
It's incredible. It's actually awesome. So what happens at the end of second life batteries? Is there a third life batteries? Is there a fourth? When is a battery properly dead?
So if I just go back a step, I guess, maybe talk a bit about the mobile batteries.
Yeah.
Because what we're doing is we not only do we have the stationary batteries, but we have these mobile batteries. We call them power skids, and they are 100 kilowatts, 150 kilowatt hours of second life batteries, and we use them on grid-tied applications. So as a plug-and-play solution, we can bring it to your site, plug it into a small grid connection, which isn't sufficient for your peaks that you've got on your load side. We plug it in, that battery peak shaves, fairly common word, or use case, but what's different to a normal battery is it can be set up in half an hour. And so we can peak shave on that, and let's say we do some temporary charging. That battery needs to maybe discharge 150 kilowatt hours at a time, right? Because it's got a truck coming in, like we're doing with the Renault Vertilus program. We are providing these alongside fast chargers for people who don't have enough power at their depot to do that charging. A battery in that kind of application might need as much energy as possible to enable that truck to charge from 50% to 100%, topping up a fairly weak grid connection. But then other applications we do might be on temporary power, so where there's no grid connection available and people are using diesel generators or
construction sites.
Sites.
I saw you guys did you did Glastonbury, or you did a big shoot, it was BBC or Netflix or something you guys did.
We
something very impressive, the logo, when I saw it.
We've continued our relationship with Extreme E, so we've now got 4 batteries and increasing with Extreme E. We've done some festivals, Big Weekend and stuff like that. And we've done some film set stuff, so we've done The Crown and a few other productions as well.
The Crown.
Fast and Furious.
Did you get to go on Fast and Furious? Did you get to go on who got on set?
So we actually work with partners in these industries. So we obviously, Zenobe, are not set up to be running around film sets, understanding what a best boy and a gaffer are. Very important people in the electrical side of a production, but you might not know. I didn't either. So we work with partners.
I know what a director and a cameraman looks like.
Yeah, exactly. Well, but in the film industry, we work with a company called Eviz, and they've deployed these batteries onto those kind of sets. So I myself didn't go onto the set of The Crown, although I did go to the set of Fast and Furious 10.
As if there's 10 Fast and Furious. That's the real story here. How is there 10 stories? Is anyone from the original one still? Obviously, rest in peace.
Well,
a couple of people.
I did want to rename our battery Vin Lithium. But
really good. We even got a laugh from Izzy, the producer there. That's top quality. So you Fast and Furious 10, The Crown, doing stuff on sites that I guess it's good for them because they can be a greener site and it ticks all their boxes too.
So actually what I wanted to get to is often what happens is when you're using generators on a temporary power site, people say, okay, how much power, what might we need? We don't know, but we've got 3 cameras, a cabin, a heater. Each one pulls 10 amps. Okay, whatever we think we might need, double it just in case. And that's the size generator we'll put on that site. And so what you then tend to have is large generators ticking over, powering someone's phone, charging or something, very inefficient, because if you have a very big generator running on very low loads, the engine effectively doesn't get hot enough. The diesel's not burnt properly, meaning that for every litre you put in, you get very few kilowatt hours of energy out. Because that diesel's not burnt properly, you get worse pollutants in the exhaust, and you also get build-up of materials in the exhaust and stuff, which causes damage to the equipment.
All bad stuff. Just running a generator for half of the output it needs to be on.
But part of it is because this kind of technology, while brilliant and it's got the world a very long way in some regards, is got no data around it, and so people don't know how much power they're using. They don't know what size generator is needed. Whereas the benefit of bringing a battery in, the first benefit is that instead of that generator running 24/7 on a very low load, ready for a potential peak, the battery sits there and powers the site with the generator switched off completely, when that battery obviously eventually does run out of charge, it will send a signal to the generator and run that generator at its most efficient rate, so in a sweet spot where you get the most kilowatt hours per litre, the highest fuel efficiency. That will continue to power the site as well as charge the battery. When the battery's finished charging, it then turns that generator off and continues the power site from the battery only. That means you can reduce the generator runtime. It varies depending on the use case, but that generator, instead of running 100% of the time, is now only running for 3 or 4 hours a day, so 20%, 30%, 40% of the time. And because you've increased the fuel efficiency, you've also saved 60 to 80% of the fuel consumption. And on top of that, because the battery is effectively a data-driven system, you're constantly monitoring how much power is actually being used. And at the end of that project, you can say to them, you had this size generator, but the load profile never went above this. Or in fact, the battery shouldn't have been in this situation because you had a very high load. That generator would have been running at its most consistent rate. Most efficient rate.
This is all complicated stuff, right? This is software stuff. So who's doing the software?
Yeah, so the software is part of the BMS, the energy management system that you put onto those batteries. So we work with partners on the software on island on these temporary power projects. And then if it's one of our stationary batteries in a depot where we've got our own control system, then we'll be controlling that via our own software.
So you've got your own control systems as well?
Yeah.
And then all this data, who gets to keep this data?
Well, the owner of the batteries gets to keep the data.
Which is you guys?
Yes. But that's just part of the service that we provide to our customers.
Battery as a service.
Battery as a service, exactly.
And do you have any other examples of things? I'm putting you on the spot here, but you guys are collecting all this data around stationary batteries and batteries on buses, and then now end of life. Have you learned some incredible things out of this data? Some things that maybe go against conventional thinking that you're now using in a business model?
On the fleet side, certainly, but I think Stephen's already spoken a bit about the kind of optimization you can do based on how smoothly people drive, etc. On the temporary power side, I would say what is interesting is that when you have a battery on a temporary power site, you're not really just looking at what the battery's doing. You now have an island grid and you need to worry about what everything on that island grid is doing, what the generator's doing, what the load is doing, if there's solar. And so being able to tie that together and provide that as a picture to the customer is what is really valuable with the data you get from the battery. Whereas previously they might have got some report on how much fuel they've used, some report from the electrician on how much power is being plugged in. But having a central technology collecting data at the kind of at the hub of that is really insightful. And I think in terms of a groundbreaking insight, or an insight which is changing the way that we...
You've got that look of you know something, but you don't know whether you're allowed to say it.
It's not quite
You're totally allowed to say it. It's fine. Don't worry. It's only, no one listens to the podcast. It's fine.
I wouldn't say... I'm trying to think if there's anything that's interesting enough to say, really. I think what I've learned is being able to judge if there's an issue in island grid, is being able to identify that from the behavior of the battery and from the behavior of the signals coming in and out of the battery. And what's very common is that when you put a battery into these kind of projects, let's say a construction project where everyone's been using generators for 50 years, everyone knows what it is, it turns up and it runs, and now you put a battery on there, as soon as there's a problem, everyone goes, right, that's the problem. It's
you put the battery green nonsense.
Yeah, but I mean, that would be my first thought as well if I was in that situation. But really, then you start seeing some really interesting things like how the frequency of generators goes up and down above 50 hertz, and how that can impact a battery's response, or how you can get different. An issue we have on one at the moment is exactly that. You have a generator which is not electrically governed, and then you see the frequency drifting up and down, and because the battery is effectively doing frequency response when it's on an island grid, it's the same technology that you have with the battery on the grid. It's effectively watching the frequency. If the frequency goes down, it goes, right, this grid needs more power, so it's providing power back. And if the frequency of the generator starts wandering up and down and goes down, the battery goes, right, there's a load on my input and I need to give power back to it. And then you've got a problem because you've got power going the wrong way. And so basically trying to then this kind of insight, which is fairly common for people working on stationary batteries in the grid, and you understand that batteries are responding to frequency, and then you're trying to bring it up. This is a problem that no one really had to deal with before, because if you've got a generator with the frequency that's wandering,
it just makes a different noise.
As long as the lights were on, people didn't mind, right? They don't notice if it flickers a little bit faster or slower, because you can't see it anyway. But suddenly you've now got to kind of bring those principles of balancing a grid into a very small situation, and working with customers who aren't who haven't previously been aware of those kind of problems or behaviours.
So how long do these things go on site for? Say you're doing you've got lithium diesel, or whatever you said, and you're doing
Vinlithium.
Vinlithium, sorry.
Vinlithium, yeah.
Vinlithium. And you're doing Fast and Furious 10. It's going to
Yes.
be a belter of a film.
Yeah.
And they call in Zenobe to bring in some batteries. How long do these things generally sit around on site for? Are you doing it for like a day? Is it a week? Is it a month? Is it a year?
Yeah, so
What's normal?
that one was a 3-week shoot on a location.
So very temporary. I was just checking that it's
was
not
more-
like
yeah.
temporary, but actually we've installed it for 2 years with a load of concrete.
No, it's temporary, sat in a field or a car park, something, a secure area, but secure ground. But you can bring it in and take it away in the day. You could not even unload it from the vehicle. Obviously, the shorter the project, then the more significant the logistics costs. Delivering it and removing it from site become to the amount of benefits you can provide. If it's a 1 year project, then that delivery and removal cost or time is very insignificant compared to the amount of fuel savings you can generate and the economy you can, or the value you can provide to the customer.
Okay, so now, my question that I started with at the beginning,
Yes.
and then we went down some of the rabbit holes. So when is a battery properly done? You guys are getting more
Okay.
value out of second life battery, but what about third and fourth and fifth life?
So what I was starting to say was that when you have like I said, if you have a battery which is peak shaving and providing for EV charging, you might need as much of that second life battery capacity as possible. When you then put it onto a separate project where you are, let's say, working with a diesel generator, in that, what you're doing is less so you using the capacity to power the site, you're using it more to increase the fuel economy and optimize that generator. So the site uses the same amount of kilowatt hours, but if you can optimize how much diesel is burned to produce those kilowatt hours, then that's what the battery is effectively there to do. And so for that, you don't necessarily need as much kilowatt hours in that battery system. You just need enough that you can effectively only run the generator at optimal rates. So you might go from one of those systems you might initially use in EV charging applications, then you might move it to that kind of application where you're optimizing generators or even other generation fuel cells, solar, and you're using it as a kind of flexibility tool to enable those systems to be used. And then we've actually seen that even if you have a battery on some generators and the battery isn't even replacing the generator, so it's never turning the generator off, but in fact that battery is effectively doing frequency response. And you've got a generator running, and when there's volatility in the load, instead of that generator opening its throttle and hunting that load, you have the battery responding much faster. So as a load jumps up and down, the battery charges, discharges. And we've seen that with a very choppy load, if you have a battery doing that job, so generator running, but the battery just on, catching that volatility, you can increase the efficiency or decrease the fuel consumption of that generator by 20%.
Wow.
And so that's a small battery running with a big generator, just doing that alone without even replacing that generator. And so obviously for that, you don't need a significant amount of capacity. It's the same as on the grid. If you're doing FFR, you don't need as much, you don't need a 4-hour battery or a 2-hour battery. You don't even necessarily need a 1-hour battery. It's just having that reservoir of energy that gives you that flexibility to deliver that service, which provides a value. So if you can cascade those batteries through different applications as you see fit, then you can extend that second life and maximize the value from that second life before eventually, that when they can't be used for anything, they go to recycling.
What's really cool about this is for lots of battery systems that are connected to the grid and provide services or do stuff, it's quite intangible how you measure whether they're good or bad, or whether they're doing an excellent job, or whether they're adding value. The cool thing about an islanded grid with a battery and a generator is you have this thing to measure, which is how much fuel is the generator drinking. And as long as it's drinking less fuel than it was, that battery is a net positive to that system. Which is awesome. I mean, we don't really have that kind of measurement in other systems and other types of installations. Now, two more complicated, one easy question and one more complicated one. The easy one, is there anything you want to plug? Is there a project you've worked on that you want to talk about? Or is there some sort of initiative that you guys are working on that you think the whole world who listens to this podcast should hear about?
Well, I would say that you probably don't have a massive amount of your audience who are producing Hollywood films or running festivals. I might be wrong. But a lot of your audience are probably financing and constructing large infrastructure projects. And I would encourage people to think about implementing the circular economy during the construction of those projects and using second life batteries to reduce their fuel consumption. We've obviously had them on some of our own projects where we've been building, and we've seen generators only running 10% of the time instead of 100% of the time. It's something that everyone should be thinking about. So that's one thing I'd like to plug. Other things are, I think, what we're doing with Extreme E has been really impressive and positive, and kind of scaling up the amount of batteries working in a similar system.
What's Extreme E? Can you just say?
Sure. So Extreme E is a new, or relatively new, it's the third season now. They are doing an electric off-road racing series where they travel around the world to extreme locations, and they have very exciting races. But that means that setting up a whole camp around the race in every location, but they're also being very ambitious around their reducing their carbon footprint as they do that. So bringing in new technologies, and we've worked with Power Logistics, who are the company managing the power of that, and the Extreme E team are both pushing it forwards. And what we're doing is bring in multiple batteries with multiple other generation assets like solar and hydrogen, and we're seeing or tackling challenges that, same as the grid, right? One of the problems on the grid is black start and trying to synchronize devices coming online one after the other. You see the same challenges on this kind of project where you have multiple batteries and other generation assets all trying to kick into the same network and trying to synchronize them so you have power flowing in the right way, efficiently and reliably. And that's a project where I think that's been done really well, and that's required a lot of bravery to get there, because if the lights go out during a broadcast or during a race, there's a lot of shouting, a lot of fingers being pointed. So it takes a brave team to push that forwards.
Incredible. And now, what about your contrarian view? So what do you believe that not the whole world believes, or is a little bit against the grain?
Sure. I would say that often, or even a lot of the time, a battery is not a good idea for a customer. And that we have people.
Izzy, can you edit that bit out, please?
But part of the challenge I face is that when we go to a customer with a battery, they say, no, we tried a battery, it didn't work, it made things worse, and we don't want another one. And that's, you might have some people in the industry who are just trying to push batteries, sell them to a customer, tell them about all the benefits that battery can deliver, and then let them run with it. And that is, batteries can obviously deliver a lot of benefits, but often a battery is not the right choice. If you've, for example, with a generator, if you've got a generator that's running on a high consistent load and it's already in its sweet spot of fuel efficiency, you can put a battery in that system. It is going to mean the generator only runs half the time or something, but you're just adding some inefficiency into that system.
Yeah.
That battery, you have, let's say, 12% round trip losses on a round trip cycle of a battery. And if the same amount of kilowatt hours are being consumed, and the generator's having the same amount of kilowatt hours per litre that it's running at in terms of its efficiency, then putting a battery in is you're just going to increase the fuel consumption. Everyone's going to get pissed off and say, well, what's the point in batteries? It's greenwashing, etc.
Yeah.
So, and it's the same on if someone's built a you might build a factory and you come to me and say, hey, I'm putting some solar on my factory. I need a battery, right? It's not always going to make a business case just shifting solar. You need a stack of business cases to make that battery worthwhile. And if everyone tries to sell everyone a battery just because they've got solar, then a lot of people are going to turn around and say, well, batteries aren't worth it. So my contrarian view is that you can't just throw batteries at everything and it's going to make it better.
Classic. All right. And before we finish, is there anything we should look out for from Zenobe? So any projects that we're going to see some Zenobe stickers on, or anything? Can you give us any scoops?
Sure. Well, we are hoping to use, or we will be using, one of our batteries as well as our capabilities in the charging side to enable the electrification of the Bristol to a certain festival in Somerset bus route, where previously they would obviously be operating diesel
I wonder
vehicles.
which festival that is. Yeah.
Well, effectively, we're providing electric buses from our fleet to work with the partner National Express, who are operating that bus route to the festival. But we are setting up a temporary charging station using some of our Second Life batteries to provide the necessary power.
Wow.
So that we can set that up during the event, provide the charging, take it away after the event, and deliver a sustainable route to the festival.
Is it a festival that has a particular keen interest on being green?
It is, as all should.
All right, awesome. Well, we'll be sure to check that out. And just want to say, Rob, thanks for coming on the podcast. For anyone listening, this is the second time we've had Zenobe on the podcast, and maybe we'll have them on again sometime in the future. Please do hit like, subscribe, and all the good stuff. It means the world to us. Thanks.
Thank you very much.